Brakes are fundamental to truck operation, serving multiple purposes beyond simply stopping the vehicle. They are crucial for parking, ensuring the vehicle remains stationary when not in use, and they play a vital role in various safety systems. Understanding how brakes function and the different types used in trucks is essential for anyone involved in transportation or vehicle maintenance. In this video, we'll explore the diverse applications of brakes in trucks, from basic stopping power to advanced safety features, with a deep dive into the mechanics and regulations that keep heavy vehicles safe on the road. Parking brakes are a specialized application of truck braking systems. When a truck is parked, these brakes ensure it stays securely in place. The parking brake mechanism is designed to be robust, providing reliable holding force that prevents accidental movement. This is especially important for heavy-duty trucks, which often carry substantial loads. The parking brake is typically activated by the driver using a control in the cab, and it works independently from the service brakes used during driving. Brakes provide more than just stopping power. They are integral to truck safety systems. These technologies help maintain control during emergency maneuvers and reduce the risk of rollovers or skidding. By integrating brakes with safety systems, manufacturers ensure that trucks can respond to a variety of hazardous situations, keeping drivers and cargo safe. Known for their reliability and ease of maintenance, hydraulic brakes are commonly found on light-duty trucks, specifically those classified as Class 6 and under. These brakes operate similarly to those in passenger vehicles, using fluid pressure to actuate either drum or disc brakes at the wheel ends. The emergency or parking brake is typically located on the driveline at the input to the rear axle. This system is a popular choice for lighter trucks that don't require the power of air brakes. For heavy-duty trucks, especially those rated as Class 8, air brakes are the standard. These brakes use compressed air to actuate drum or disc mechanisms, providing the necessary force to stop large vehicles. The air brakes feature separate chambers for stopping and parking functions. Drum brakes operate through a series of mechanical actions. When the driver presses the pedal, the pushrod extends from the chamber, rotating the slack adjuster. This movement turns the S-cam, which pushes the brake shoes outward against the drum. As the drum heats up during frequent use, it can expand, requiring more travel for the shoes to make contact. In extreme cases, the S-cam may not accommodate the increased distance, leading to a condition known as cam over, where braking is lost on that wheel end. Understanding this process is vital for maintaining safe braking performance, especially under heavy loads. Disc brakes offer superior stopping power compared to drum brakes. This design eliminates the risk of cam over and reduces maintenance requirements. The operation of disc brakes requires less air, allowing for smaller chambers that are positioned perpendicular to the wheel end, protecting them from damage. While air disc brakes are more expensive, their reliability and performance make them increasingly popular in modern trucks, especially for applications where safety and efficiency are paramount. The operation of disc brakes is straightforward yet highly effective. Pedal action extends the pushrod, rotating the eccentric lever, which multiplies the force to push threaded tubes and tappets. This spreads force evenly across the inner and outer pads, pressing them against the rotor. The absence of the S-cam means these brakes do not fade and cannot cam over, ensuring consistent performance even under extreme conditions. This reliability is a key reason why disc brakes are favored for heavy-duty applications where stopping power and safety are critical. Runaway truck ramps are a vital safety feature found on highways, especially on long downhill stretches. These ramps provide an emergency route for trucks that have lost their brakes due to mechanical failure, overwork, or cam over. The presence of these ramps underscores the importance of maintaining brake systems and being prepared for unexpected failures, ensuring that even in the worst-case scenario, there is a way to avoid disaster. Air brake chambers are essential components in truck braking systems. The chamber is divided into two sections. The service brake portion, shown on the left, controlled by the brake pedal, and the spring brake portion, shown on the right, used for parking. The spring on the parking brake side is extremely powerful and under high pressure. If the clamp on the chamber breaks, the chamber can explode with force similar to a bomb, making safety precautions critical when servicing these parts. During normal driving, the brake chamber is filled with air, pressing on the diaphragm and compressing the parking brake spring. This allows the vehicle to roll freely until the service brake is applied. The spring brake is disengaged and the service brake side is ready to respond to pedal action. This configuration ensures that the vehicle can move smoothly while maintaining readiness for immediate braking. When the driver presses the brake pedal, air fills the service brake side of the chamber. This air pushes the diaphragm, compressing the smaller spring and extending the pushrod. The pushrod then activates the slack adjuster on drum brakes or actuates the pads on disc brakes. This process occurs on all axles, ensuring consistent braking across the vehicle. To park the vehicle, the driver pulls the yellow valve on the dash, depleting air from the brake chambers. This action allows the spring brake to take over, securing the vehicle. On tandem drive axle chassis, there are typically 4 spring brakes, sized according to the vehicle's gross weight rating. These brakes are strong enough to hold a fully loaded truck on a 20% grade. Contrary to popular belief, if a vehicle suddenly loses air, the brakes engage rather than fail, providing a safer alternative to a runaway vehicle. The Federal Motor Vehicle Safety Standards are enforced to keep the roadways safe. Tractors and trucks have distinct air brake systems, regulated by FMVSS 121. The chamber size must be sufficient for the GVWR of the vehicle. Tractor weight is relatively low until coupled with a trailer, which adds supplemental brakes to the system. Understanding the differences between tractor and truck air systems is important for compliance and safety, as each configuration has unique requirements based on weight and operational needs. Full trucks often have a greater loaded vehicle weight than uncoupled tractors. To address this, a spring brake modulator or inversion valve is used as a safety mechanism. If the truck loses primary air, the spring brakes supplement the service brakes, allowing up to 5 applications in the event of air loss. This system ensures that even in emergencies, the vehicle can be brought to a stop safely. Anti-lock brake systems, or ABS, are mandated for heavy-duty trucks and tractors. ABS works with the air system to modulate brake pressures, preventing wheel lockup and maintaining maneuverability. This technology is a cornerstone of modern truck safety, reducing crashes and fatalities. ABS is integrated with other safety systems, enhancing overall vehicle control. The National Highway Traffic Safety Administration reports significant reductions in accidents and fatalities due to ABS, highlighting its importance in heavy vehicle operation. ABS uses sensors and modulators at the wheel ends. Sensors detect lockup events, and modulators proportion air to the brakes, controlling application and release. This rapid modulation allows the brakes to apply and release quickly, preventing skids while the pedal is fully depressed. The sensors are maintenance-intensive, requiring recalibration due to vibration. They are connected to an electronic control unit, ECU, which processes signals and manages brake modulation. Proper maintenance of these components is essential for reliable ABS performance. ABS comes in several configurations, such as 4S4M, which places sensors and modulators on 4 outer ends. The steer axle receives a set for each end. This setup is common in single-drive axle chassis. It can also be used on tandem drive groups where only one drive axle is sensed and modulated. In this design, the rearmost axle is typically controlled as it is most prone to lockup. This configuration provides effective braking for most vehicle setups, ensuring safety and compliance with regulations. ABS systems are rigorously tested to ensure they meet mandated stopping distances and safety requirements. If a configuration fails to meet these standards, it becomes ineligible for certain ABS setups. Design teams work to maximize safety at the time of build, but ongoing maintenance is crucial. A dashboard light alerts drivers and technicians to system failures, allowing normal braking to be used if ABS is compromised. Relay valves ensure that even unsensed axles mimic the modulation of sensed axles, maintaining consistent braking performance. 6S6M ABS provides maximum protection for tandem drive axle configurations. With 6 sensors and 6 modulators, each outer end is monitored and controlled, offering superior reaction time during lockup events. There are also options for 6S4M, where forward and rear drive axles share modulators. On tridem drive axles, relay valves are used to control one of the 3 axles. The plumbing and configuration can vary by manufacturer, but the goal is always to maximize safety and performance. FMVSS 121 sets stopping distances for vehicles, with requirements evolving over time. Before 2011, tractors needed to stop within 355 feet at 60 miles per hour. To improve safety, shorter stopping distances were imposed. Manufacturers and suppliers worked to ensure vehicles met these standards, often exceeding requirements before mandates were enacted. Phase 1 of Reduced Stopping Distance, or RSD, was implemented in August 2011, shortening the requirement to 250 feet for 3-axle tractors under 85,000 pounds. Manufacturers had to provide testing data to prove compliance, leading to changes in brake size and materials. This phase significantly improved safety, though some uncommon configurations were not tested and, as such, became unavailable. Phase 2, enacted in August 2013, expanded stopping distance regulations to a wider range of vehicle configurations. The same rigorous testing and documentation requirements applied, resulting in improved stopping distances for most tractors. For configurations that went untested, approval is still possible but requires additional testing and cost considerations. These ongoing efforts ensure that trucks continue to meet high safety standards, protecting drivers and the public. Automatic Traction Control, or ATC, was developed to address the issue of spinning wheel ends on low-friction surfaces. This system is effective on loose gravel, ice or mud, but was never intended to replace locking axles in off-road situations. ATC is required on most tractors today, providing enhanced vehicle progression and safety. ATC systems utilize the ABS to apply brakes as needed, effectively transferring power to wheels with traction. Transmissions with hill hold features can keep the chassis from rolling backwards for a few seconds while the driver moves their foot from the brake pedal to the accelerator. This system relies on signals from the ECU regarding wheel end speed. On tandem drive chassis utilizing 4S/4M ABS, one axle has no sensors. This creates the potential for both wheels on the unsensed axle to spin at high speed without ATC activating. This can occur without driver knowledge and introduces the potential for a spin-out failure. For that reason, on tandem drive axle tractors, where ATC is required, 4S/4M is highly undesirable. 6x4 tractor chassis should always choose 6S/6M ABS. ATC remains optional on full trucks and can be disabled in certain conditions, such as when locking axles are used. If the drive axles are spinning and the vehicle isn't moving, ATC may apply brakes excessively, causing the engine to derate and reducing power needed to clear obstacles. For this reason, ATC can be turned off at low speeds and is automatically re-enabled at higher speeds. Understanding these limitations helps drivers use ATC effectively without compromising performance. FMVSS 136 mandates stability systems for over-the-road tractors with Phase 2 expanded coverage in 2019. Stability systems, such as Electronic Stability Control, or ESC, and Electronic Stability Program, or ESP, reduce crashes due to rollover or directional loss of control. These systems use sensors and algorithms to monitor vehicle behavior and apply brakes when necessary. Rollover protection is currently optional on full trucks, but its effectiveness where applicable is well documented. Yaw control addresses the out-of-control angle slide and potential jackknife during turns. Using ABS braking and sensors, the system keeps the tractor and trailer aligned, applying brakes as needed to maintain control. The ECM records vehicle configuration and uses algorithms to predict expected behavior based on speed and steering input. This advanced control helps prevent accidents caused by loss of traction and inertia, ensuring safer operation during challenging driving conditions. Adaptive Cruise Braking, or ACB, and also known by the terms collision mitigation or brake assist, uses forward-facing radar to monitor the distance between vehicles. When the gap closes beyond a safe range, driver alerts are issued and automated braking occurs if necessary. In extreme cases, engine power is reduced to prevent collisions. ACB is part of a suite of electronic monitoring features that move trucks closer to autonomous operation, integrating braking functions with lane departure monitoring and adaptive cruise control. Truck brake systems are complex, combining mechanical, hydraulic, and electronic components to ensure safety and performance. From basic stopping power to advanced features like ABS, ATC, and ESC, each element plays a crucial role in vehicle operation. As technology advances, brake systems continue to evolve, offering greater protection and efficiency for drivers and the cargo they move. We hope you have found this information informative. If you are a first-time visitor, please subscribe and be alerted of additional content designed to educate you about the design and operation of heavy-duty trucks.